We're back in this series. Today we're looking at linear quadratic symmetries equation. Now what it is just basically a pair of equations where one is a straight line and one is a curve. Alright, so for this one, the elimination method is not going to work. We got two methods that we can use. We can either use the substitution method or the graph method. This video I'm going to be showing you how to use the substitution method. Now once you have a pair of linear, one is a straight line, quadratic, one is a quadratic equation, we have to definitely go to the substitution method or the graph method. Now the substitution method just states that we're going to take the linear equation, we're going to rewrite it in function or in terms of one of the variables, and then we're going to put that into the quadratic equation so that we only have one solution or one variable to look the solution for. So what we're going to do is that we're going to take the linear equation, we're either going to choose the x or the y, and we're going to rewrite it. So in this case we're going to write it in function of the x. We see that x is equals to 2 plus y. How we got 2 plus y? This minus y, we're going to transpose it over here. So we know that anything across the operating sign changes, so it becomes, it's shifted from minus y, to positive y. So that's a third equation. Next, we're going to take the third equation, we're going to put it into the second one. So anyway, we see x here, we're going to not going to put x, we're going to put 3 plus y. So we're going to put 3 in 2. Remember, if you put an equation back into itself, you're going to get 0. So we have, the equation was xy equals 15. So we took out the x, and we're going to change it for 2 plus y. So now this y could have been at the back, at the front. When you're multiplying, it doesn't really matter, but because we are so accustomed to having the variable at the front, I put the y at the front. So we have y, and x is now 2x plus y is equal to 15. So what we did is that we basically took out the x and we're only working with the y. So now we're going to remove the bracket using the distributive law, which just means that we're going to multiply the 2 and the y by the y that's outside. We multiply everything inside by what's on the outside. So we're going to say 2 times y and y by y. So 2y times 2 gives me 2y, y times y gives me y squared, and that is equals to 15. The next thing that we'll have to do is to take this and put it into this format, the quadratic format, which is ax squared plus bx plus c is equals to 0, which means we have to shuffle around these things a bit so that it looks like this. So that means that this y squared has to come over here, this b come here, and this c has to come here. Let's see what happens. So the y squared goes first, the bx or by with this will becomes here, and then this 15, it was over here. To get it to come over, he had to move from here with his positive and come over to become negative. It's positive here, when I transpose over, becomes negative. So we have y squared plus 2y minus 15 is equals to 0. Alright, so now we can look at solving this. Now these numbers are relatively small, so we can think about using the factorization method here, splitting the middle term. So what we do is we're going to multiply the first number by the last number. So we have 1 times 15, we got minus 15, and then for that minus 15, now we look at the factors that are minus 15. So when I add them, I get 2. The factors of minus 15 are 1 and 15 and 3 and 5. Now, if the 5 is positive and the 3 is negative, 5 minus 3, we got 2. So these will be the factors that when I multiply them, I'm going to get negative 15, and when I add them, I get 2. So what we did is that we took these factors, so we have y squared plus 5y minus 3y minus 15 is equal to 0. Alright, so now what we're going to do now, we're going to check to see if we can factorize this by using the HCF. Of course we can, because there's not one number besides 1 that can go into all of them without the remainder. So then what we'll have to do is have to factorize. Now grouping just states that we just have the pair of these. Pair them off. So we pair off this and we pair off that together. So now we end up with y plus 5y, that's one pair, and minus 3 minus y is equals to 0. So now we're going to look for the HCF, the common thing that they have here, which would be, they both have y squared, 5y, they both have y over here. So to go factor out the y. Now once we factor out the y, we're going to say y into y squared, leave back with y. Y into 5y goes 5. Over here, what can we see that they have in common here? They don't have the y in common here, but they have a number. That number, 3 can go into 3 and 3 can go into 15, so they both have 3 in common. So and they both have a negative sign, so I factor out negative 3. Once I factor out negative 3 now, I say negative 3 into 3y goes y, and negative 3 into negative 15 goes positive 5. We equals that to 0. Alright, so now, because we have 2y plus 5, we bring that down in one bracket, and then the y minus 3 put in another bracket, we equal all that to 0. Alright, so now, next, it's time to solve. Let's find the values. So we have y minus 3 is equals to 0. So we take this minus 3, we took it over. So we made from negative to positive, y is equals to 3. Then on this side we have y plus 5 is equals to 0. This 5 is positive. So we took it over and it became negative. So we have our next solution, y is equals to minus 5. Now remember, quadratic equation where the linear quadratic has an x variable and a y variable. So we found the values for y. What we're going to do now is find x. Now how do we find x? Remember that first equation that we had, x minus y equals to, if we have the value for y now, you can substitute that value here to find the value of x. So in this case, we have y, the first value, y is equals to 3. So we have x minus 3 is equals to 5. We work out the bracket. So this becomes x minus 3 is equals to 2. This 3 is going to be transposed over here. So we end up with x would have been equals to 2 plus 3, and 2 plus 3 gives me 5. On this side here, same equation, but now we're checking to see if y is equal to minus 5, what would be the answer? So we have x minus, and remember y is minus 5, so we put in the bracket is equals to 2, we work out the brackets, we say a negative and negative give me positive. So x plus 5 is equals to 2, x is equals to 2 minus 5. When this is transposed, the sign changed, and we know that 2 minus 5 is equals to 3. So those are the solutions. So solutions is when x is 5, y is 3, and when x is minus 3, y is minus 5. Now what that means is that if this was the graph for the straight line, and this would have been the graph for the quadratic equation, these points here, minus 3, 5, and 5, 3 would represent where the line cuts the curve. The solution of the line cuts the curve. Alright, so let's do a little test to see the answer that we found were actually correct. So we have x minus y is equals to 2. We say that x is equal to 5 and y is equals to 3. So we put that there. There's nothing to work out here, so we move the bracket. So we have 5 minus 3. Do we get 2? 5 minus 3 gives me 2. So we know that these pair of coordinates are correct. Over here we had when x is minus 3, y was minus 5. So we have, put them in the brackets, we have minus 3 minus 5. We get 2. So let's work out. So there's nothing to multiply here, so we've been on the minus 3 here. We work out here, negative and a negative. Give me a positive. So we have minus 3 plus 5 gives me 2. So we know that these answers that we got were correct. And that's it. Remember, a linear quadratic symmetry equation can be solved by using the graph or by using the substitution method. The substitution method just basically states that you're going to take the linear equation and you're going to put it into the quadratic equation, so that when you end up, you only have one variable to focus on. Once you have done that, then you can solve the quadratic equation by using any method, whether it's the factorization, splitting the middle term, completing the square, the quadratic formula. Alright?